Hey guys, it's Kyle from Fixed Dish, and I am doing something new. I'm actually learning how to 3D print, and I'm going to print something that will help me in my job. And thought I would just kind of share with you some of the different stuff that I'm doing. So today I'm designing JIS plugs, and I wanted to share with you that I figured out that through McMaster-Carr you can get the files from there, but there'll be some adjustments you'll have to do. So I'm going to go ahead and share that with you. So what I have here are my master pieces. These are caps and plugs that are JIS. They're Japanese standard, or Japanese industrial standard. It's a 6 and a 5. These are my finished pieces right here, but going on McMaster-Carr, I got the files for these. We're going on to McMaster-Carr, and here is our product that we're going to be using. In this case, I looked up caps and plugs, and for JIS, it's also known as BSPP, but JIS is Japanese Industrial Standard. And I went in and picked a size that I would like, and then when you pull up your size that you want, in here they have the CAD file that you can look at the product detail, and you can also put it in different modeling. So I went ahead and printed it in a step file, and that way I can put it into, and I downloaded it, and then I put it into my slicer. So here are my parts in my slicer. Now to show you this kind of how this works, let me move these off to the side here. I am going to go ahead and pull over my files. Okay, so there's my two new pieces that I brought in over here. Now, for printing purposes, I don't want to print like that. So I want to, lay this on its back. And then we want to scale these projects. So it's not just that you can go in there, save the step file, put it into your slicer, print it, Bob's your uncle, and all of a sudden you have caps and plugs. There's some stuff that you have to do here. So you have to imagine that this is a subtractive manufacturing, and with subtractive manufacturing you start out with this billet piece, let's say hex stock, and you have your tool coming in here, and the G code tells it to machine away until you end up with this perfect shape. Okay, well, you're following this exact piece with your tooling and manufacturing that away. With 3D printing, it's additive manufacturing. So you have to imagine if you're instructing it to go right here, but then depositing a layer of filament, the filament has size to itself. So when it's printing exactly on that line, as you can see, there's a difference between cutting up to this point and then printing on that point. It's thicker. To prove this, here's our masterpiece, or our original G code, and I went ahead and printed the file as is. So this is the file as is. So this is exactly these pieces in G code. They do not fit each other. They are close, but they don't fit, they don't thread, they don't do anything. They also don't fit into that piece or this piece. They don't even begin to screw in. So with that, we need to figure out how to scale this appropriately. The best way I figured out how to do this was basically taking some calipers and measuring. So for example, this is a 1650 millimeter. Measuring on this. This is a 1680, and that's where my first challenge came in, that I figured out these are not perfectly round. I printed a bunch. I've printed it in different quality, different speeds. They are not perfectly round. They're close, not perfect. So what I did was I took a measurement of my sample, and I basically divided out between the two to figure out how much smaller this was than the G-code print, and I came up with a percentage. Well, depending on which piece you measure, whether it be the cap or the plug, it's actually different. That comes into another thing called interference fit. You have to have some clearance for these to fit into each other loose enough that you can thread them. So I went ahead and settled with originally printing it a 5% smaller piece. So I printed this 5% smaller, this 5% larger, and put them together. Now they fit really, really well to each other, and they actually fit pretty well into the masterpiece. But that's not the point of this. We want we're replacing these pieces. We're substituting them with these. So we want these pieces to fit like these pieces. So it doesn't matter that they fit each other. It doesn't matter that they fit in there. We want them to fit like these fit. So you want to take a measurement and see how close you are to the original. Now, in doing this, I went ahead and printed a 2.5% scale. So cap 2.5% larger, plug 2.5% smaller, and measured these, and then also tried them into their masters. Now, if you remember right, I noticed that these don't print perfectly round, and so in doing this, the plugs fit fairly well. The caps, oops, that's the 5. The caps are slightly tight. That's because they're not roundness inside there. It fits, but it's tight, but it fits. So the next thing I did is I wanted to see if the scaling would work no matter what size of piece I used, or no matter what size file I used. So I went to a 5 on the JIS. Same thing applies. I tried a 5% print, 2.5% print. One thing I noticed about the 2.5% on the smaller ones, they barely fit into each other. That fits very tightly into the master. So as you get smaller, you actually have to get more accurate. So that's where you run into a little bit of complication, because I can't be accurate because these don't print perfectly round. So I need to find a happy medium. So what I ended up doing was I printed a mix. I found that typically the caps fit better 5% larger than the file, and then I went ahead and did 3% smaller with the cap. That's where I come up with these. Now they fit well to each other. They fit well into their print, or into their master. They fit well. These fit really good on the larger ones. The smaller ones, it's okay. Again, the smaller you go, the more accurate you have to become, which is difficult to do. Those fit perfectly, but this plug, it's a bit tight. It will go if I were to use a tool. I want to be able to hand thread them in and then use a tool to finish it off. So I might have to go to like a 3.5% on this one to make it fit appropriately due to the out of roundness it is. So like I was saying before, we'll need to scale this down because the master file is too large, and we'll want to keep it in a uniform scale. So we'll go ahead and scale this down to 97%, and it will scale all axes down to 97%, and then I will do the same for this piece. Oops. We will scale him, but he needs to get bigger to fit over the piece. And we said 5% was good for him. Leave it uniform scale. Scales up 105%. But we are additive manufacturing in the G code. The way that it wants to cut the piece or move is it is moving in this counterclockwise way, which in 3D printing will make you a left-hand thread. We need to fix this. To fix that, you can mirror your Y and you'll see it flipped it to a right-hand thread. So with that being said, we have now scaled this down, scaled this up, made sure the threading goes the right direction, all using the step file from a CAD program for a subtractive manufacturing piece. And now we can go ahead and arrange these on the plate. Then we can change some of our characteristics. I printed several in a standard quality. These are going to be more of a finished design. I'm still running in a hyper PLA just for prototyping, but I want to see how a fine quality works, so it's a lot more accurate. I did change my seam to random, and the reason being, when I preview this, is you have to have a seam somewhere. I haven't learned how to use scarfing yet. I think that'll help when I learn how to do that. But the little white pieces here are seams. Now, with such a small piece, you could probably crush these down enough when you torque down on it, that having it random like this, hopefully it will seal appropriately or seal enough. If you were to have, let's say, your seam aligned, there's enough material there that it'll actually stop it from seating. That's not what we want. You'd actually have to probably machine that out. And I'm trying to keep as little processes as little process as possible, post-processing. And it's not true just for that piece, but it's also true for the plug. So for now, I'm going to leave this as random until I do some testing to see how it works, to see if it will seal appropriately. Again, this is just for temporary sealing. It's not to like put hydraulics in service. It won't withstand that. It won't withstand those pressures. This is just to keep hoses clean, and that way if I lose them, it's not a big deal. They're cheap. And then the other thing I did was I changed the infill, because there's a little bit of infill in here. I wanted to be somewhat strong, so I did the adaptive cubic. I found that to be fairly strong. And that's really all I changed from some of the factory settings. So then from there, we would export our G code into my thumb drive, because I haven't set up my online deal yet. Export my G code. It would go into my thumb drive, and then we would eject that, put it in the 3D printer. Bob's your uncle, and we're all done. Now this is all hyper PLA. That may change a little bit when I go to ASA, when I print my final product. I want high UV resistance, chemical resistance, etc., etc. So I think what I'm going to do is print an ASA. I think that'll be probably the most appropriate for what we're doing here. But I mainly was sharing with you that on McMaster-Carr, you can go on there and get your CNC files. You can print the step file into G code, and you can 3D print with it. But there's a difference between subtractive manufacturing and additive manufacturing, and you will need to measure and then scale appropriately. Remember, if you're trying to fit into something, you want to scale down. If you want to fit tighter, and you'll need to scale up for something external if you want it to fit looser. So like I said, this is 100% file. They don't fit into the masters. This needed to get smaller. It got scaled down by 3%. This got scaled up by 5%. And that's where I end up with these that appear as if they will work as a stand-in for my caps and plugs for capping and plugging off hoses. That's all today from Fixed Dish, and I hope I was able to teach you something. I'm still learning myself, but if this is something you like and you want to see more of it, let me know. But we'll see you next time on Fixed Dish.